because this is probably something you want to look at in slow motion time.
Yep.
Okay, sorry about missing that. We'll record everything from now on, so it is recording. Where was I? Okay, in this question here, there is no U sub to be done. If you ever get a sine squared on its own or a cos squared on its own, there is a trig identity that you're going to have to use. Now, there's sine squared can be written as 1 minus cos squared. No use to you. That particular one doesn't help. But there is another one. It's a half 1 minus the cosine 2 theta. And for a cos squared, it's 1 plus the cosine 2 theta. So you're going to have to use those identities to turn sine squared and cos squared into these fellas. And to finish this, and then we'll look at some homework questions. If you had to integrate that fella, the antiderivative of cosine 2 theta is sine of 2 theta. Is there anything else as well?
Times 2.
That's differentiation.
Divided by 2.
Right? If I was here, I'd have my funny little thing where I say, look, I've got my differentiation hat on, or I've got my integration hat on. And when you do U subs, you do a bit of differentiation, but you also do a bit of integration, right? So you have to be aware of where you are in the process. And trig functions are notoriously bad at making that mistake. So it's dead easy, isn't it? You differentiate a sine, you get a cosine, right? But what do you do when you integrate a sine? You get a negative cosine. See, they switch on you. And it's easy, you know, it's easy to get caught up in that. And all that'll mean is that you'll type in the answer, you know, 42, and it should have been 21, right? And where did that, how did that happen, right? Something like that can happen.
Or 42, and then you get 11 when you're supposed to get 11 and a half.
Correct, because I've done it, and I've doubled it when I should have halved it, so you're right. So it would be 11, 10 and a half. You all know the reference to 42, of course.
Of course.
Jacob, you do not know the reference to 42? Hitchhiker's Guide to the Galaxy, the meaning of life and everything?
It's the answer to the ultimate question of life, the universe, and everything.
42.
The problem is
42.
we don't know what the question is.
You have to watch the series. The British series is much better than the movie. And then you'll know what that reference is. So, not all references, I guess.
Listen to the radio show. Either way.
No, I haven't, but I do intend to one day. Okay, ready for homework questions, because that's going to be really your issue. If you tell me a question, I'll do it. Otherwise, I'll just pick random ones from the same list. Who's got one to start the ball rolling? Now, do we have one? That's fine.
Can we do 6?
Okay. I've got them all printed here, so I don't need to zoom in and out all the time. Okay, it says use a double integral to find the area of the region, one loop of the row. So they only want an area. Interesting. Oh, that's interesting. So it's not really a double integral after all, isn't it? It's just a single integral.
Oh, really?
Yes. Oh, no, it says use a double integral. I apologize. It is use a double integral. Oh, God, that is silly. Okay, now I know why. Okay. Here is why this double integral is the same as a single integral. The guy that we're trying to do is one loop of the rows r equals 8 cosine 3 theta. And I'm going to go and put on a calculator. And hopefully you can share the screen of this guy. Right. Now, if you do not have a TI-84 calculator, well, let's check first. Are you seeing a picture of the calculator? I can't hear it. Yes, you're seeing nods. That's good. Okay. If you go on to Canvas, you'll find out how to get this program. It's made by TI, the people who make the calculators. It's an emulator, and you get a 90-day free trial. So if you don't have your own TI-84, you can use this for 90 days, and if you like it, you can buy it. So hit mode. Make sure everything is in radians because it's calculus. Move over to polar. Hold on a second, I'll close the door. My wife's having... We are both working from home, and her office is in the bedroom next door. So anyway, so I could hear her conversation. I don't think you wanted to. So we got polar. So I've just set it up. Now I want to see what this Stella looks like. So it's 8 cosine 3 theta, and I'm being asked to find one PEL. So 8 cosine 3 theta. The window should be 0 to 2 pi, which it is. And so I should only need to go zoom to 0 to see it. Those petals do not look the same shape. But they are the same shape, it's just the calculator isn't a square. The calculator's a rectangle. So you see that that leaf or loop to the right-hand side looks skinnier and longer than the other two. Can you just pretend that they're all the same size? Right. So if you wanted to find the area of one of those, couldn't we find the area of all three of them and then just divide the answer by 3? Right? So if I'm looking at how this function would be created, right? I can now stop sharing and hopefully return to my screen, right? That's meant to be the picture. Let's see how I would create this ship. So let's find out how to do D. Well, if you generate the shape, you can do theta from 0 to 2 pi. That would basically scan through the whole shape. And then what about R? Well, R is going to go from 0 to 8 cosine 3 theta. So can you imagine I was projecting various lines off the center? Each one of them would be a different length. Like each one of those little R's, those little radial distances, and they would equal that number there. So this is the fellow that I've got here. So what's my double integral going to look like, and who's my f of xy going to look like? Well, it's going to go from theta equals 0 to theta equals 2 pi. And I'm going to come back and show you a better way of doing this after this one. I've got to go R, whoops, a second one. I'm going to do R equals 0 to R equals 8 cosine 3 theta. And then I'm going to go R, dr, d theta. And then you might say, but who's the f of xy? And the answer to that is, it's 1. When you calculate a double integral, you're essentially getting the volume, right, from the area going upwards. If you make it go upwards 1, aren't you basically finding the volume of an object whose height is 1? But if the height is 1, isn't the volume of the object the same number as the area?
Mm-hmm.
So that's kind of the logic of why that was throwing me, because I was seeing that not quite the same way. What I've got here then basically would be all 3 loops. So I'm saying let's just divide the thing by 3. I want to tackle it a slightly different way.
Could you integrate it as a single integral and plug in
And then just
R?
multiply it by 2 pi. Exactly. That's why I was thinking it was a single integral. Because remember, that there would be just 1 d theta. And that would get you 2 pi. I'm going to change the game a little bit here. Let's look at the angle that would make that petal there, right? This one up here. If you want to find the angles, right, the values of theta, what you're looking for is when is that 0? Because when that is 0, you're basically coming in at the ends of the loops. So at that point there and at that point there, the R value would be 0. And so that means I'm looking for when is the cosine of 3 theta equals 0, which means I'm looking for when is 3 theta. Right, when's a cosine equals 0? Well, it equals 0 at pi upon 2. And
Negative
then,
pi upon 2.
say again?
And negative pi upon 2 or 3 pi upon 2.
Yeah, negative pi upon 2 because of the shape, which means what? Pi upon 6 and negative pi upon 6. So actually I put that there before I actually made sense. This thing here could be negative pi upon 6 and this thing here is positive pi upon 6. And that way I don't need to divide anything by 3. And that's a much cleaner version of the question. Now, if we split it up, oops, don't split it up, take it back. Stopped it in time. Calculate this guy the usual way. So I'll rewrite this again because I made a mistake. Well, I fixed it, but it's still messy. This is the guy that we had, so you don't need to rewrite him. I'm just doing it for my benefit. You are not allowed to split this shit up like we could do in some of the others. And the reason is that the limits are not numbers. These limits contain variables, which is what I was about to do, and then I stopped myself. No. Focus on this guy with dr. Well, you get a half r squared, evaluated at 0, and evaluated at 8 cosine theta. That would get you 1/2 8 cosine theta squared, take away 0, so I won't take away anything. So that's 32 cos squared theta. So this is what our working would look like. Right. Talked about this guy earlier today. If you want to integrate cosine squared theta, don't you have to replace it by, looks like my dog has come in to see what's going on. Right, so
1/2 1 plus cosine 2 theta.
right, so if I do the half together, we're now looking at that fella. And then, you know, it's a fair amount to do, but the hard part's over, right? I think we're going to have to say hi. Come on.
Wait.
What do you want?
We're missing a 3 on the thetas.
Check that out. I'll put that in. Okay. These should have been, where's the 3 on the theta? Sorry.
The original one, which was the r equals 8 cosine 3 theta.
Oh. Thank you. Oh, that's going to be, I think I should take this a little bit further then. Do you see the guy that was looking like cos squared 3 theta? he will turn into 1/2 1 plus. When this is 3 theta, this gets you double it. This becomes 6 theta. So, whoa, there was a lot of sneaky things going on there. Are we cool with that now?
Sneaky, sneaky.
Sneaky, yeah.
Yeah, thank you.
Right. Okay, that one was quite a... And it's such a... I mean, it's such a tiny looking question, you wouldn't think there was anything in it. But there was an awful lot of little things going on in it. I think my job, apart from the fact that I'm easily distracted, as you can tell, my dog's managed to do that for me. You just have to be careful in these questions. It's so easy to do 90% of it right and still not finish the correct answer. Okay, what's our next question? If we have one, I'll take it. Otherwise, I'll just pick something. Okay. Let's see what we got. Okay, I think it's time we kind of bit the bullet and went on to one of the bigger questions. And so we're going to use polar coordinates to find the volume of a given surface that lies between two surfaces. So the one I've got in front of me is question 8. And we have one shape that's written as z equals x squared. I've lost the guy. Where? No. I think I've just merged two questions together. Okay. We'll do 11. That's the one I wanted a question that had more than just what 8 had. Okay, so we're using a shape where we have a sphere, which is x squared plus y squared plus z squared equals 25. And then we have a cylinder, x squared plus y squared equals 4. And we're using polar coordinates to find the volume of that shape. Now, whenever you find a double integral, you're finding the volume of something. So if I look at these two questions, what we're looking at is we're finding the volume of a shape made up of what would happen if you put both of these together. Not even going to attempt to be really accurate. Can you imagine that's a sphere? And can you imagine there's a cylinder going through it? Can you imagine when these two things interact, there's a shape that looks a bit like a cylinder with some curved bits? God, that's why I don't draw shapes, right? All we need to worry about is it's the volume between two shapes. So the first thing we need to know is who D is, because you always have a D and then you have a double integral. Now D is going to be the intersection of these two shapes.
Wouldn't that be only on two planes, the x and y plane? So it would just
Yeah.
be
Yes.
radius 4.
Yeah. We actually know who D is. Who's that? Okay, we got an easy one. Can we pretend that said x squared plus y squared plus z equals 4, so both were 3D shapes? What I was about to do is I was going to solve the two equations and tell you what it was, but since it's there, we can do it. Now let's describe him. Since he's a circle, and it's a whole circle, I'm assuming there's nothing. We got that? And so what's the volume going to look like? Well, the volume is going to look like the double integral over D. of our function. This guy is not written in the format that it needs to be. We need the function to be written as z equals a function of x and y. And that's what's going to go here. And then we'll do the r d theta stuff. Right, so I'll take that to the side. And this would be what my working would look like. When I'm finished, it's going to say z equals, at least it better.
Square root of 25 minus y squared minus x squared.
Great. Now for the steps, 25, take away x squared minus y squared. Well, I didn't need anywhere near that one, right? Now, what does that tell me z is in terms of r or theta? Well, if I rearrange it like this, do you see that z is now 25 take away r squared? So that's basically who our function is going to be. It's just going to be that guy. No theta's in it at all. So back to our volume. It's going to be the integral from theta equals 0 to theta equals 2 pi. The r value is going to be 0 to 4. Our function is going to be the square root of 25 take away r squared. Remember the r dr d theta? We good? Now, what are we going to do with this fun thing? I've seen something really nice. Can I do this as a split? Now, can you see why I'm allowed to, in this case, get away with two separate single integrals? Aren't the limits of integration only numbers? Check. Can the function be separated as two things multiplied? Well, in a very trivial way, yes. A 1 times everything else. Now, this guy here is very easy. He ends up being 2 pi. Right? So, I know that bit. And since I want time, maybe even attempt at least the start of the next one. This integral here is Calc 2 world. This integral requires us to use a technique. What method should you use to find this integral?
You do a u sub with r squared.
You should, shouldn't you? You also recognize that? Would it be just r squared?
25 minus r squared.
Right, the whole package. I'm not doing it. It's messy and it's ugly, but it works, right? And you'll get ugly answer times 2 pi, and your answer will end up being whatever, 17/43 pi. You know, you never get 2 pi, it seems, anymore. It's always ugly fraction pi.
Every time.
Are we good? Any more questions about that one? Right. So if I don't find one of these double top guy takeaway bottom guys, I'm going to scream here because there should be one. I think I found one. Just needed to look a little bit further. And this is question 12. And the function we've got is above a cone. So z equals the square root of x squared plus y squared. And it's above this guy. And it's below this guy. Okay, so in this case, I need to find who D is. D would represent the floor, right? The bit that you would integrate, right? And you get it by finding the intersection of the two above. Now, these could be anything, and there's all sorts of ways to solve things. So I'm going to do my version. You know, this guy here could also be written down as z squared equals x squared plus y squared. Would you agree that's the same information?
Yep.
Right. I find that's going to play well with this guy. Because if z squared equals x squared plus y squared, can't I replace this z squared with that? And now what I get is x squared plus y squared plus x squared plus y squared equals 49, which is 2x squared plus 2y squared equals 49, which becomes our typical circle. Do you recognize that as a circle? So D is a circle. Right? Now, what kind of circle do you get? Well, when you get circles, the theta is dead easy. If it's a whole circle, that's the theta. But won't the R be 0 to, not 49 halves, right? You know, if it was x squared plus y squared is 9, wouldn't R be 3, the radius? And isn't the radius of this a rather ugly 7 over root 2? Which I'm now going to call 7 root 2 over 2. So our double integral will be from theta equals 0 to theta equals 2 pi. And R equals 0 to R equals 7 root 2 over 2. Now we've got the next piece of the puzzle. What goes here? Well, do you know when you did Calc 2, you took area between two curves? Didn't you do top curve, take away bottom curve? I want you to think of this in the same way. You're going to take top guy, take away bottom guy. But it has to be written in this format. So it's going to be, this guy's the bigger of the two. So if I rearrange this, it looks like that. But doesn't that give me that guy? Which I'm skinning through this, but can you trust me, it's 49 minus r squared. So it's going to be the square root of 49 take away r squared. That's this function here. And then take away that one. Oh, what's this guy? Isn't he the square root of r squared, which is just r? So top function converted into r's and thetas, in this case really r's. Take away second function. Right, that's the second function, ends up being r. This fella, when you do a bit of work on him, ends up being this fella. Big guy, take away little guy. Remember the RD theta still here? Our thing's going to be this fella. Right, we don't have time, so I'm going to have to just talk through the last parts. This integral is going to be the volume we're looking for. Do you see that I can split it into this bit here and then a 1 d theta of this guy? Okay. So we really only need to find out who he is and multiply it by 2 pi. Now, when I look at this question, that guy there is just a power rule. And what would we need to do to get this r square root of 4 minus r squared thing?
The same thing that we did for the previous question 11.
Right. So
that should be a 49 right there. I think you dropped the 9.
Yeah. So what we would do then is a u sub with 49 take away r squared. So if you do enough of these, the algebra, although it's ugly, seems to repeat itself a lot. You end up doing similar things, you know, more than once in different questions. Whew, that's a lot to take in, right? At least you don't have a quiz to worry about, right? So your main focus is going to get this guy done, and then that's your weekend free if you get it finished by today. So if you get stuck on anything, as always, drop in, tell me what's going on. I'll try and help you. Chances are that you'll need to do a Zoom meeting with these, because I really think it would be hard for me to do this by email. Just
If I was
horrendous.
seeing the working on that one, it'd be like, okay, how did we get to here?
Are you talking about if I was doing an email? Yeah, it would not work. That's me for today. If anybody has got any questions, as I say, drop me an email. We can figure something else. We can figure it out. Otherwise, I won't see you until probably next week, where we'll be starting our next bunch of questions. Kawika, could you hang on for a few minutes? I need to talk to you, please.
Yes, sir.
Okay. Well, bye-bye, the rest of you. Bye-bye, Andrea, Jackson, Jacob. We'll see you
Have
soon.
a good weekend.
Thanks. Take care.
You too. Stay safe and have fun.
Thank you.
Thank you. Have a good day.
You too.